Hello, I welcome you my afternoon lecture number 4. Previously we have taken 3 lectures on power station engineering and the topic was thermal power station. So, today I will discuss about the governing of steam turbine and comparison between impulse turbine and reaction turbine. Before discussion, I will give some data of our country where 10 biggest thermal power stations are existing in India. So, first is Vindhyachal thermal power station in Madhya Pradesh, whose capacity is power generation capacity is electricity power generation capacity is 4760 megawatt. And second one is Mundra thermal power station in Gujarat. Their capacity of electricity generation is 4620 megawatt. Number 3, Mundra ultra mega power plant in same Gujarat. It is a private one that is managed by organization is Tata Group, and the power generation is 4000 megawatt. Next, number 4, biggest thermal power is Sagar ultra modern power plant, whose capacity is 3960 megawatt, and it is constructed by Reliance Group. Number 5, Tiroda thermal power station in Maharashtra. It is the owner is Adani Group, is a private company, and his capacity is 3300 megawatt. Number 6, in our state Odisha, Talcher super thermal power plant. Generally it is called NTPC because the public sector name is NTPC, but the plant name is Talcher super thermal power plant in Odisha. Our capacity is 3000 megawatt. And you know the NTPC means National Thermal Power Corporation. It is the organization which under which all government plants are built, thermal power plant. It may be gas based or coal based. Out of these plants, most of are located near the river. In Odisha it is near the Brahmani river. In other state they are adjacent to the river bank, near the river, because water is a major requirement in a steam power plant, because steam will produce from the water. If water is not available in a large amount, you cannot produce steam continuously. So, therefore, all the power plants, thermal power plants are located near river. Next 7, Riyadh thermal power plant in Uttar Pradesh. It is also central government NTPC. Here also the same 3000 megawatt. Number 8, Sipat thermal power plant in Chhattisgarh. Their capacity is 2980. Their state government is the owner of the plant. Next is number 9, is Chandrapur super thermal power station. Chandrapur Chandrapur super thermal power station, its capacity is 2920 megawatt. Its capacity or output is 2920 megawatt. Megawatt is 10 to the power 6 watt. And number 10, last one is, last biggest plant is Dadri National Capital Power Station. National Capital Power Station. That means it is in New Delhi, near New Delhi, national capital. Dadri National Capital Power Station is located in New Delhi. That means it is actually in UP, but very close to Delhi. In River Jamuna bank it is located. Its capacity is 2637 megawatt. Here it is having two plants, what is coal based, whereas fuel is coal based power plant. Out of these, coal based generation is 1820 megawatt, and the gas based units are, where the gas is the fuel, gas based it is 817. Total is your 2637 megawatt. So this is one unique, where the plant consists of two types, one is coal based, another is gas based. The rest 9 all are coal based plant, but here it is coal based as well as gas based. So this is the data in India and in our country, the thermal power stations. Similarly, we are also able to know what are the diesel power plants in India, any diesel power plant, hydraulic power plants. So, like this is the data for super thermal power stations in India. Super thermal will be called when the unit capacity will be more than 500, minimum 500 megawatt, or exactly 500 megawatt, then it is called super thermal. So these 10 are super thermal power stations. Now I will discuss what are the comparison between impulse and reaction turbine. The name implies itself, the impulse means force into time, that is called impulse. That is equal to change in momentum. That is where the change in momentum is responsible for the force. But in the reaction turbine, there is change in momentum as well as some reaction force developed. Therefore, the name is reaction turbine. And here both the turbines are used in power plants, and we will see what are their difference between them. Let us make a table. impulse turbine, in this right hand side reaction turbine. Number one point, an impulse turbine has fixed nozzles that orient the steam flow into the high speed jets. Already we discussed that the impulse turbine has fixed nozzles that orient the steam flow into high speed jet. But in a reaction turbine makes use of reaction force produces as the steam accelerates through the nozzles formed by the rotor. That means, in case of impulse turbine, there is one fixed blade where you get the high velocity jet striking the velocity at V, absolute velocity V. But in reaction turbine, the blades are curved unsymmetrical, so that there is some reaction produced in the reaction turbine, because here the relative velocity is greater than initial. So, there is some drop in pressure, therefore, one reaction force takes place. Here only impulse force, here impulse force as well as reaction force. This is the difference. Number two, blade profile is symmetrical as no pressure drop takes place in the rotor blades. So, here the blades are symmetrical blades. Symmetrical means they are like your semicircular, the blade size is semicircular. So, it is called symmetrical, but the reaction turbine is a non-symmetrical blades, non-symmetrical. That is your aerofoil section, aerofoil, the shape like your aeroplane blade. So, the blade of the reaction turbine is similar to the blade of aeroplane. So, it is aerofoil section, non-symmetrical. it is because there is no pressure drop takes place in the rotor blades. It is जो हमारे रोटर ब्लेड रे जो अच्छी कौन ब्लेड्स आर मूविंग ब्लेड्स आर ओल्डेड और माने in the rotor blades, therefore, there is no pressure drop in the rotor blades in impulse turbine, only in the nozzles. One fixed blade is there, so there the pressure drop takes place, but here the rotor blades pressure as well as velocity changes. Number 3, suitable for efficiently absorbing the high velocity and high pressure. At a high velocity and high pressure, it is most efficient in high pressure and high velocity. In both cases, this turbine will efficiently perform, but it is not in reaction turbine. It is only in low pressure. It is efficient in a low pressure condition, low pressure steam. It will work efficiently, but impulse turbine will work at a high pressure, high velocity. It is similar in case of also impulse turbine, also there is in where water can be also used in that is called water turbines. In that case also impulse turbine is a high pressure turbine and reaction turbine is a low pressure. It is quite similar. steam turbine and water turbine. In both cases, this comparison is same. Number 4, steam pressure is constant across the blades and therefore the tip clearance are not necessary. एटी होची कौन ना प्रेशर remains constant throughout its path in the rotor. Steam pressure is constant across the blades and therefore tip clearance are not necessary. Pressure, since pressure is constant throughout the blade in the turbine rotor, so there is no necessity of any clearance between the two blades, two running blades. Here, in case of in this reaction turbine, inefficient at high pressure stages due to the pressure leakage and the blade tip. Since it is there is some pressure drop from P1 to P2 or boiler pressure to condenser pressure, here there is a chance of leakage. So, across the blade tip, it is inefficient in high pressure stages. Number 5, last one is efficiency is not maintained in the lower pressure stages. It is efficiency low pressure it is the high pressure turbine. If low pressure is low, so it is not efficient. Same thing in the same manner, find the clearance can cause damage to the tips of the blading. So, due to these clearances can cause damage to the tips of the blades. It is clearance roila between two blades, so it will damage to the blade. So, this is all about your comparison between impulse and reaction turbines. Another turbine is also there. This is 50% impulse and 50% reaction. That is called impulse reaction turbine. That is also used in steam power plant. The last part of my is governing of steam turbine. So, let us see the diagram. In this is the one power plant having boiler, turbine, condenser and boiler feed pump. This is the boiler and this is the steam turbine and this is the condenser and this is the boiler feed pump. And in between boiler and turbine one control valve is situated, which controls the quantity of steam passing to the turbine. That means it controls the fuel or the working fluid of the plant, that is the steam. It controls the steam which is generated from the boiler. So, it is control, not that always steam is flowing in a constant amount. It depends upon the load. Even if you switch on one electric bulb in our house, then the turbine regulation will takes place inside the plant. It is very sensitive for load. So, without load, even your electricity generation will not take place. That means steam flow will be stopped if there is no load. So, this is the one principle of working showing the different. So, here this governor is located and this is the signal coming from the turbine shaft, speed signal, kete speed re turbine ta rotate karuchi, and it is, this is the valve is opened by the governor. Steam control signals. This will give the signals to the, this is the signal point, steam control signal. It will give this the control valve, so that the valve will open or close depending upon the demand. And suppose in winter season or in the night the load decreases. It is because there is no necessity of an AC in fans in a office or any where. So, in a night, in midnight our load is very less. So, at that time the governor will supply less working fluid to the turbine, so that generation of electricity will be also reduced. So, the main task I will explain. The main task of the governing system are to start the turbine from rest and run it to the rated speed and synchronize with the grid. So, governor main function है, it will start the turbine. That means the plant will operated by the governor. The plant will start the turbine, the governor will start the turbine from rest condition and run it to the rated speed, that is 3000 rpm, and synchronize with the grid. And synchronize means grid जेतिकी consume करिवो हमरो powers, सेतिकी power synchronize हो माने समान हो, जेतिकी produce हो plant रे सेतिकी consume हो, excess होबनी कि less होबनी, that is synchronizing. It is the work of the governor. Number 2, to meet the load variation when running in parallel with the other machines. ये जो हमर एटा जेतले मु कहली जेतले लोड वेरिएशन हबो, लोड कम बेसी हबो, that will be controlled by the governor. Number 3, to protect the machine from abnormal and emergency situation. कौन सी machine जदि suddenly बंद हो गला कि तार लोड कमी गला, It will protect the machine from abnormal and emergency situation like overspeed trip, बेसी स्पीड ट्रिप हो generator protection. So that is protected by the governor. Number 3 है to stop the turbine from normal rated speed condition to stand still. It can also stop the machine. जो start करुला plant, it also stop the plant. Suppose if the load is increased, that means electrical load, just like fan, AC, any machines, workshop, jete सब load अछि ता कहते electrical load. If the load is increased, जदि बेसी machine हम चलेले, the speed of the turbine starts decreasing. तेणु turbine speed कमी जीवो. कहीं load बढ़ी गला हठात तो turbine speed decrease करिवो. To bring the machine to its normal speed, the steam valve is open to allow more steam. तेणु जेतले हमर ए valve टा open हो केतले ना जेतले धरा हमर turbine रे load decrease करी गला. तेणु speed टा बढ़ी जीवो, ए turbine रो speed टा बढ़ी जीवो. तेणु बढ़ी गले कौन हबो ना turbine shaft may bend because there is no necessity of running at a high speed without माने consumption of load. The turbine if it rotates, electricity there is no consumption, so there will be imbalance between the load and input and output. That the input is your turbine power to the generator, so output is the electricity. If input and output will be vary at that time, the turbine rotor may bend or shaft may damage. So therefore the governor will takes place the governing action by allowing less quantity of steam to the turbine at that time. So this is the principle of working of the governor. This is the speed sensor here governor, it speed कमिले और valve टा open close से अनुसार होगा. Similarly, if the load is reduced, if the load is increased, the speed of the turbine starts decreasing. To bring the machine to its normal speed, the steam valve is open to allow more steam. अधिक steam दब जदि तो load बढ़िला माने हमर steam भी बढ़िया दरकार. से भलिया similarly, if the load is reduced, the turbine starts accelerating, and to bring the machine back to the rated speed, the steam flow to the turbine is reduced. तो लोड रिड्यूस हेले तमर स्टीम फ्लो भी रिड्यूस हम. लोड बढ़िले स्टीम बढ़िबो, लोड कमिले स्टीम कमिबो. The speed change caused by load change is sensed by a device called speed sensing device. It is shown. Corresponding to the difference between the design speed and the actual speed, a signal is generated which actuates the control valve to establish steam flow to the machine. तार माने जो स्पीड सेंसर अच्छी से गोटे कांस्टेंट स्पीड सेटा सेट है. जदि जो कांस्टेंट सेट स्पीड थारु जदि कम बेसी हैला, then it will actuate the valves. Now I will discuss one governor which is used in the plant, that is your mechanical governor. Like mechanical governor, other governors are also there, hydraulic governor and electrical governor. Now I will discuss one mechanical governor. This is a spring loaded Hartnell governor which controls the steam flow to the turbine. This is your mechanical governor, this one. These are the different link, the two link, it is ball, the ball, this is a one rotating shaft, it is connected to the turbine shaft. This shaft of the governor connected to the turbine shaft. That means it is getting power from the turbine shaft. That means speed of the turbine can be sensed by this mechanical governor. Jodi speed कमिला ताले governor shaft तार rotation भी कमिबो. And एटी दीटा balls लागिची से ball rotate करिवे. Ball जत्ते speed rotate करिवे अधिका speed if it rotates, then this sleeve, it is called sleeve. Sleeve टा ऊपर उठी जीवो. If sleeve will rise, then this is your fulcrum. This is part A, this is part B. That means it is this part A will also go up. Then what will happen, since it is a lever like fulcrum, so the B will come down. It will come down. Down hole kon hobo, this steam passing to the turbine will also reduce. This case happens when there is a decrease in load. Decrease in load. Decrease in load हेले कौन होबो ना इलेक्ट्रिकल लोड हमर पावर जनरेशन कमी गला यूटिलाइज माने कंजम्पशन कमी गला तेनु टर्बाइन रो स्पीड बढ़ी जिवो से समय when the turbine speed will increase that will be connected to the governor shaft, so then this shaft also rotate at a high speed. Then the total balls, two balls will rotate at a high speed. So it will go up. So then the valve will closes. So then the steam supply will reduce. So then it will be synchronized. That then it is safe for the plant. So that is safe to the turbine. So the turbine shaft will not bend or any bearing will not damage. Reverse case, when the load increases, increase in load. Increase in load हेले कौन होबो ना shaft turbine shaft speed टा कौन होबो कमी जीवो कारण लोड अधिका अछि किंतु संगे संगे कौन होबो ना turbine shaft टा कम स्पीड घूरिबो कम स्पीड घूरिले हमर एटा भी कम स्पीड घूरिबो कोडा हमर मेकानिकल गवर्नर जो हार्टनेल गवर्नर अछि ये भी कम स्पीड घूरिबो. This is also discussed in your theory of machine, this mechanical Hartnell governor. ताले कौन होबो ना जेतले कम स्पीड घूरिला तन बॉल गुडा भी कम स्पीड घूरिबे तेनु एटा रिवर्स हो जिवो स्लिप टा तळु पळि आसीबो डाउन हो जिवो डाउन हैला माने कौन होबो ना एटा फलक्रम अछि तेनु ए लिवर भलिया ए बी टा ऊपर उठी जिवो तेनु ऊपर उठी गले तेनु स्टीम बढ़ी जीवो एटा तेने भालटा ऊपर उठी जीवो तेने अधिका स्टीम विल एंटर इनटू द टर्बाइन. So this is the way how the governing of power plant steam turbine takes place. So this all about today. Next one is another mathematical part of this portion is your governor regulation, very important term. You should know governor regulation. This is defined like this. This symbol is R. R is equal to N0 minus NF by NR into 100. This regulation is equal to 4% for thermal power station, thermal power plant, and it is equal to 2% for hydraulic power plant, hydel power plant. Here N0 is no load speed, no load speed, that means when the valve closes, load नथिला माने एटा स्टॉप कर देबो टरबाइन को, no load speed. When the valve closes fully is called no load speed. Then it is NF, full load speed. When the valve is full, the speed at full load is called full load speed. Full load speed. R is NR, mean speed or rated speed. It is your rated speed. It is say 3000 rated 3000 RPM. So this is the N0 minus NF by NR into 100. This is called governor regulation. Low load speed generally it will be very high, full load कमी जीवो. This is a positive value. This ratio is your governor regulation. Okay, this for today it is now finished. I am finishing my lecture. So thank you all.